This topic is on transforming exponential and logarithmic functions. In the Algebra 2 textbook, you want to turn to page 537 for the transformations of exponentials, and on page 538 for the logarithms. Please make sure you pause and do that now. What we're going to go ahead and do is graph an exponential function and then a logarithmic on the same graph. This should be a review for you. So you want to first pick some values in your domain for x. So -2, -1, 0, 1, 2. Then you evaluate it, you substitute it in, so 4 to the -2 power is 1 over 4 squared, or 1/16. 4 to the -1 power is 1/4. 4 to the 0 power, anything to the 0 power is 1. Then 4 to the 1 power is 4, and 4 to the 2 power is 16. So I'm just going to graph 3 ordered pairs. -1/4, -1 up 1/4, over 0, up 1, and then over 1, up 4. So just a few ordered pairs to get our shape. Then our logarithm, if you remember, is the inverse of our exponential. So what we do is we flip-flop the ordered pairs in the red. So now we have 1/16, -2, 1/4, -1, 1, 0, 4, 1, 16, 2. And again, let's just pick these 3 ordered pairs to graph. So over 1/4, down 1. Over 1, up 0. Right 4, up 1. And then here's the shape of that graph. A couple pieces here for domain and range and asymptotes. The domain for this red function is all real numbers. Every number can be plugged in, so -infinity to infinity. The range is going to be y is greater than 0. Its asymptote is horizontal at y equals 0, and it has a y-intercept of 0, 1. In the blue, the domain is numbers greater than 0 for x. The range is all numbers for y, so -infinity to infinity. It has a vertical asymptote at x equals 0, and it has a x-intercept of 1, 0. Now we're going to go ahead and apply some transformations. So here's a transformation where we are -4. So what this -4 does is it shifts the original, what we call the parent function, down 4. So if you think about its original function, f of x equals 3 to the x. If I come back to this slide, look at y equals 4 to the x. If I just try 3 numbers, -1, 0, and 1, without the transformation, this is 3 to the -1 power, or 1/3. 3 to the 0 power, which is 1. And then 3 to the 1 power, which is 3. If I graph that function first, those 3 ordered pairs, it'll look like this. So -1, up 1/3, over 0, up 1, over 1, up 3. Here is the traditional parent function for f of x equals 3 to the x power. Now what we're going to do is we're going to shift our ordered pairs down 4 units. So you may want to just go ahead and recreate these ordered pairs. So my x-axis does not change at all. But my y-axes are going to be shifting down 4 units. So 3 minus 4, I'm now at -1. 1 minus 4, and then down 4 units. So that's how that one goes. And then 1 down 4 units, where would I be? At -3. And then the next one, -1, down 4 units. So -4, we get -3 and 2/3. Or you can pick up these ordered pairs and shift them down. So this ordered pair, shifting 4 down, would be 1, 2, 3, 4. This ordered pair, down 4 units, 1, 2, 3, 4. And then this ordered pair, 1, 2, 3, 4. And now there is my exponential function with its shift down 4 units. What would be the domain? It's still the same as its parent function, -infinity to infinity. Its range now has a horizontal asymptote at y equals -4. So the values have to be greater than -4. And then it has an intercept of over 0 down 3. All right, here is a exponential function. But what happens when you have a negative in front of the function? So I do want you to take a moment in your textbook and identify what happens when you have a negative in front of the function. Will it move it up? Will it move it down? Will it reflect it? If it does reflect it, what will it do? So take a moment to do that. Okay, you should have found on page 537 in the bottom box, if your negative is in front of your function, which it is, it's going to reflect about the x-axis. You remember those transformations that we learned earlier in the school year? That's what these are talking about too. So it's an easy way to just graph this original 3 ordered pairs on the previous slide. -1, 1/3, 0, 1, 1, 3. Graph those first. That's your parent function before your transformation. Like such. Now, we want to reflect it about the x-axis. So where is the x-axis? That's your horizontal x-axis. So imagine taking a piece of paper on the x-axis and reflecting it. So this ordered pair is now here. This ordered pair is down 1. And then instead of going up 3, we're going to go down 3. So my domain is still the same, -infinity to infinity. My range is what kind of numbers can I plug in for y. Notice that this value is decreasing, so y has to be less than 0. My asymptote is still the same, it's horizontal, at y equals 0, at that green line. But now my intercept is right here, over 0, down 1.